Hello everyone, welcome back to the channel Code with AKJ. Today is day 39 of solving Geeks for Geeks problem of the day. So today's question is missing and repeating. It's the interview question being asked in many companies like Amazon and Samsung. So let's move on to the question. Here given an unsorted array ARR of positive integers, one number A from set 1 to n is missing and one number B occurs twice in array. So we need to find these numbers A and B. Today we'll be solving a coding problem where we are given an unsorted array ARR and where a number is being missing and a number is being occurred twice in this array, and we need to find these values A and B. So we'll tackle this problem starting from the brute force approach and then we'll move on to the optimal solution. So given here inputs ARR 2 and 2, here in this case 2 number is being repeated twice. So our repeating number would be 2 and the missing number here would be 1 as the size of the array is 2. So we'll return 2 and 1 as an output. So coming to the second example here, 1, 3, 3. Here we can easily see that the repeating number is 3, which is being occurring twice, and the missing number in this array would be 2 as the size of array is 3. So we need to solve this problem in expected time complexity, which is O of n, and space complexity should be O of 1. So let's analyze these two examples and let's get on with the brute force solution. So here I have written these two array values and the size of these arrays. In our first case, the repeated number would be 2 and missing number would be 1. And in our second case, the repeated number would be 3 and missing number would be 2. So by observing these two examples, we can easily find out a brute force solution where we can sort this particular array and we'll compare the value with its previous number. If both are same, then we can say that the repeated number is being found. And to find this missing element, we can compare that current element with the previous element. So since it should be in a sequence order, the previous number plus 1 should be equal to the current value. So if it is not, then we can say that we found our missing element. So finally, after finding this repeated and missing number, we can return it in the form of vector. So this is our brute force solution. So here our time complexity would be O of n log n, where we have used the sorting function, and space complexity would be O of 1 as we are not using any external data structure. So let's move on to the code and let's see whether it gets accepted or not. So this is a code for the brute force approach we have discussed using these two examples. Here I have taken the size of an array and answer vector. I have sorted the array which would take O of n log n times. I have taken two variables repeating and missing, which would be initially -1. I have iterated over this array from the index 1 as we need to compare the previous element. So if the current element and the previous element are same, then we can say that we found our repeating element. And if the current element is greater than the previous element plus 1, then we can say that there's an element missing in between these two elements. So we can say that our missing element is the previous element plus 1. So after finishing this for loop, we can find our repeating and missing. So before returning it, we should handle these two cases where we need to check the first element and the last element. So we need to check that the starting element is being present in its order or not, where the starting element should start with value 1 and the ending element should end with the value size of the array, which is n. So we'll handle these two edge cases using this if else condition, and after these steps we can easily push back these values into our answer vector and finally return our answer vector. So here our time complexity would be O of n log n and space complexity would be O of n. So let's try to compile and run this. It's working, so let's submit. As you can see, it got accepted, but while this works fine for smaller inputs, we can optimize it further, as our expected time complexity is O of n and space complexity should be O of 1. So we need to find a way where we need to optimize our time complexity and we'll reduce from O of n log n to O of n. So let's move on to a more efficient solution using mathematical properties. So here's the plan. We'll calculate the actual sum and current sum of this given array and actual sum of squares of elements and current sum of squares of elements of this given array. And we'll use these values and we'll calculate in such a way that we'll find our repeated and missing element. Since the actual solution would give us the actual value and the current sum will give us a current value and the difference of this would give us our missing element. So in this way, the same goes with the sum of squares of elements. We have taken this sum of squares of elements just to calculate the values of b and a. So here b is our repeated element and a is our missing element. So the equation goes like this. As we will calculate our different sum, which is b minus a, and the sum of squares of elements, which would be b square minus a square. So since b square minus a square is our b minus a into b plus a property, we'll calculate the b plus a value, which is square difference sum by b minus a. So in this way, we'll have our two equations, equation 1 and equation 2. We'll solve for a and b. Here both a cancels and b becomes the difference sum plus square difference sum divided by 2. In this way, we'll get a repeated value, and when it comes to missing, take this b value and put it in this equation to get our missing element. So in this way, using a single iteration over our array, we'll find this current sum and sum of squares of elements, and using our mathematical properties, we'll find our repeated and missing sum. So here in this approach, we'll use a time complexity of O of n and space complexity of O of 1, which is our expected time complexity and space complexity. So I hope you understand this approach. So let's move on to the code and let's submit this. So this is a code for the optimal approach we have discussed through our mathematical properties. Since here we are squaring the values, it can go beyond the integer limit, and hence I have taken long here. So I have calculated the expected sum and squares of numbers from 1 to n, which is our actual values, and I have taken the current sum and sum square, and I have calculated the given arrays sum and sum of squares. And using these formulas and equations, I have calculated the required differences, and finally I have solved for both a and b and returned this a and b in the form of vector. So let's compile and run this. It's working, so let's submit. As you can see, this problem got accepted as well. So here our time complexity and space complexity is matching with our expected time complexity and space complexity. So that's it for today. We have seen both a brute force solution and an optimal solution for finding the missing and repeated numbers in our unsorted array. So here the brute force approach involved sorting, while the optimal approach used mathematical properties for an efficient solution. So if you found this video helpful, so don't forget to like and subscribe for more daily coding tutorials. Also let me know in the comments if there's a particular problem you want me to solve. See you in the next video. Thank you.